So this is just a continuation of the unit circle and even and odd trig functions and how to do sine and cosine tangent and all that on your calculator. But the first thing they talk about is sine and that's not a very good color. What did you just do? Take my keys, Miss Lindgren? Let's do purple. Turn the lights off.
Yeah.
Sure. I don't know why I just wrote it. Sine, turn the lights off. And cosine are periodic. Okay? Sine and cosine are periodic. I already talked about this. Periodic, meaning they repeat. Okay, they repeat themselves. Repeats every, how often?
2 pi.
Every 2 pi radians. Okay, and when we get into graphing these trig functions, you will see when we get into graphing them, where along the x-axis you have time, or you have what else? Usually time or degrees or different types of things. But you'll see that these trig functions go up and down like that. We talked earlier, like that could be the distance of a planet or distance of a satellite from Earth, or the distance of Earth from the sun at various points in time, or it could be tides going up and down, or it could be a sound wave. So there are lots and lots of things in real life that are periodic like that, okay? And so that's how we model them. And I gave you a problem where, so for example, let's do like the tangent, just for fun. Let's do the tangent of 50, oh no, we don't want to do tangent. Let's do the cosine of 57 pi over 4. So if they said that, so what I want to do is figure out how many pi's over 4 is one revolution around the circle. 8 pi's over 4, right? So what you want to do is figure out how many 8 pi's over 4 are there in here, and then what's left over when I'm done with putting 8 pi's of 4 inside. Yeah, so you could just, I mean, you could, if you want a mathematical method, I'll give that to you in a minute, but 8 pi over 4 is the same as 2 pi, right? So you could count, you could say I'm going 1, 2, 3, 4, 5, 6, but Luke said how many are there?
7.
Why?
Because there's not 8.
There's not, well, 7 times 8 is what?
56.
56, right? So there's 7 of these in here. So basically, if I divided 8 into 57, right? If I divided 8 into 57, I get 7 with 1 pi over 4 left over. You get that?
Yeah.
Okay, so I go around the circle 7 times, and then I'd have 1 pi over 4 left over. So this could be written as the cosine of 56 pi over 4, which is 8 times 7, plus pi over 4. And so then that, since it's periodic, it repeats itself every pi over 4. Pi over 4 is over here. And what's the cosine of pi over 4?
Square root 2 over 2.
Very good. Root of 2 over 2. Because when this is pi over 4, this coordinate is root of 2, comma, root of 2. And so it's root of 2 over 2. That's a 2. Second part. Okay? So that's equal to, this is equal to the cosine of pi over 4, which is equal to root of 2 over 2. Oh, now you're ready to learn the math here.
Yes.
Yes.
We are.
What?
We are. We're ready.
You know it already
Oh, yeah.
from geometry. So Sam and who else could recite it for me? Emily and Catherine, do you remember the math here? Are you like a pom-pom or something? Haven't you been doing this at the football games?
No.
No? Oh, okay. So I'm very disappointed in you. Okay? It goes like this. Okay? Do you want to come here and dance it for us?
No.
Okay. All right. You don't have to write this down.
Oh, we don't.
No. I learned this my second year of math teaching from this very good teacher. Okay? Let me make sure this. Okay, ready? How do you say this? Root of 2. Root of 2, right? Root of 2. Okay, so here we go. Recite after me. Ready? Matt? Ready? Okay. Yeah. I need everyone to participate. Okay? Ready, set, go. Root of 2, 2. Root of 2, 2. Root of 2, root of 2, root of 2, 2. Root of 2, 2. Root of 2, 2. Root of 2, root of 2. Go, Matt, go. Okay. All right, that's my favorite thing. Anyway, so moving. Mrs. Voss is yelling at me. All right. So anyway, that's math here, and it comes up a lot in trigonometry. So the domain. So we'll talk about the domain and period of the other trig functions, but for right now, we're just talking about domain of sine and cosine. And who can tell me what the domain of sine and cosine are? Other than what possible? What possible values can I plug in for the domain of sine and cosine? Can I plug in negative 576 pi in there? Sure, yes. So the domain of sine and cosine is all real, because I could go around the circle as many times as I want. Sometimes I write this like with a funny looking R like that. Okay? What's the range? What are the possible outputs? What's the biggest sine ever gets? No.
2.
1. What's the smallest sine ever gets?
-1.
Negative. So the range goes, including the endpoints, you could write this like this, -1 up to 1. And the reason for that, if you want to think about it a little bit, I know some of you don't like to think too much, but the ratio, no matter, so if I just draw a picture in the first quadrant here, okay, remember that sine is the opposite side over the hypotenuse side. Well, the opposite side can never be bigger than the hypotenuse side, right? And so it's never going to be bigger than 1, which is not the case with tangent, right? Because can the opposite side be bigger than the adjacent side? Yes, okay, so when we get to tangent and cotangent and those trig functions, they'll kind of talk about that, okay? Then we have even and odd functions. Can I grab this whole chunk? I don't know. Can I start a new page? Is that okay? Even, odd, even or odd. Sine. So even are cosine, which we call COS, right? And secant. Did I spell out the words longhand the other day?
No.
One is cosine, which we've abbreviated COS, and secant, which the common abbreviation is secant. Okay? Is secant. I don't know, I just say stuff. So what this means is if I take the cosine of negative x, that's equivalent to the cosine of positive x. Okay? And likewise, the secant of negative x is equal to the secant of positive x. So for example, if I wanted the cosine of negative pi over 3, okay, that's equal to the cosine of positive pi over 3. And you could kind of see that if I were to draw a unit circle. Okay, I should just have this in my quick file right here. But if I were to draw a circle and negative pi over 3, that means I go this way 60 degrees, right? And positive pi over 3, I go this way 60 degrees. See why it's even?
Yeah.
Because x is the same in both of those cases, right? So that's why it's even. Does that make sense? Make sense to everyone? Okay. Odd are the other trig functions. So odd, we have sine. That's S-I-N-E, but we abbreviate it sin. So sin of x, sin of negative x is equal to negative sin of x. Okay? And cosine, well, not cosine, its reciprocal, cosecant of negative x is also equal to negative cosecant of x. And the tangent, right? Tangent of negative x is equal to negative tangent of x. And cotangent of negative x is equal to negative cotangent of x. And so, for instance, say I wanted the tangent of negative 2 pi over tangent of negative 2 pi over 5. I don't know what the tangent of negative 2 pi over 5 is, but I could either find it using my calculator that says 2 pi over 5, or I can take tangent and plug in negative 2 pi over 5, or I can take the negative tangent of positive 2 pi over 5. Okay? And the reason that that works is, again, looking at the unit circle, you can at least, do you understand what I'm doing? No? Why is there so much giggling going on? It's not that funny. Where would negative 2 pi over 5 be? Where would negative 2 pi over 5 be? Which quadrant?
1.
I might ask you a question like that on a non-calculator question. 3 or 4?
3.
Oh, wait, never mind. 4.
Because 5 pi over 5 would be over here, right? Negative, right? Negative, so if I want to know where negative 2 pi over 5, right? I think you would be in the 4th quadrant, wouldn't you?
Yeah.
Yes, because pi is over 5, this is 5 pi over 5s, right? So this would be 2.5 pi over 5s. You kind of see how I'm thinking, okay? So this would be negative pi over 5. Where, negative 2 pi over 5, where would positive 2 pi over 5 be?
1st quadrant.
In the first quadrant, okay? So, is tangent negative or positive here?
Positive.
Negative or positive in the 4th quadrant? Negative. So in order to find the tangent of negative 2 pi over 5, I could take the positive tangent of 2 pi over 5, but then I would have to make it negative. That's why I stick that negative sign in front of it, okay? So these are even, these are odd, and we will see when we graph them that they take on the properties graphically of tangent of, Okay. The other thing with math, don't do this, okay? Don't do this. This is a bad math error. You know how this works? Oh no, that's equal to 1. That equals 1, right? Because you can just go like this. You can cancel out the ends, right? And then you get 6 over 6, which is equal to 1. Don't do that. That's bad. Yeah, it's kind of a dumb math thing. You know?
I get it.
Oh, like 6 over.
Yeah, right. Okay. Anyway, so that's that. There's just 1 or 2 more things. So, how do you take the cotangent of something? So say they ask you, what's the cotangent of pi over 3? You guys know how to do that?
That's 1/2 over root 3 over 2, right?
So you could do it 2 ways. Yeah, so cotangent, you don't hit the second button on your calculator. And your calculator doesn't have a cotangent button. It just has a sine, a cosine, a tangent, and then it has inverse sine, inverse cosine, inverse tangent, which are not the same as cotangent. And so these are reciprocal functions versus inverses. The inverses are what angle do I plug in if I get out pi over 3 and stuff like that, okay? So to get cotangent of pi over 3, I know that cotangent is 1 over tangent of pi over 3, okay? Because those are reciprocals of that, each other. So if you know the tangent of pi over 3, which I think is root of 3, so this is equal to 1 over the square root of 3, and the reciprocal is of that. What's the reciprocal of that?
Root of 3.
Root of 3. Okay? So you take the tangent of it and then you flip it over. If you were doing, say you did something like this on the calculator, what's the cotangent of 397 degrees? You know how to do that?
You have to put it into radians.
First you'd have to be in degree mode. You can plug it in degree mode. So you take your calculator, make sure you're in degree mode. If they give you a degree problem, I've been trying to talk in radians as much as I can, but just to show you an example. Okay, you eyes in front. So you want to go to mode and make sure you have degrees selected if the problem calls for degrees. Okay, and then you would just go. You just second quit, and you would do 1 over the tangent of 397 degrees. Or you could just take the tangent of 397, and then you could go like this. See this little x to the negative 1 up there? That gives you the reciprocal. Okay? And then you hit enter, and you get 1.32 would be the cotangent of 397 degrees. Okay? So it's 1 over whatever the tangent is. So, is there anything else? I don't think there is. Okay, so just when they say exact answer, that if they say exact, that means like in terms of pi, or in terms of like square root of 3 over 3 is an exact answer. If you give me like 0.57 or something like that, that's not an exact answer. Right? So if they say write your answer in exact form, that means you're using the unit circle to answer the question. Okay? And that's about all I have to teach you. Okay? So I'm going to